Hi, so I'd like to share today about a battery mod for the Fat Shark 18650 battery case. And I got a new pair of Fat Sharks, and they come with this battery case instead of just a battery. The old ones are a battery. This is a battery case where you put these 18650 batteries in it. And one of the things that I noticed, and I also read on the forums, was that um, you don't have any reverse polarity protection here. So, and these batteries are really bad. You can see where I put some tape on them, but they don't. These are particularly bad because they don't even say plus or minus on them, um, and so I marked them with tape. And also in the case here, you have to really peer in here to figure out which side is plus and minus. It's on the inside here, but it's not marked real well. You can't see plus or minus. Where does it go? And you're like kind of looking at it. And if you got bad vision, you're like, oh, okay, I can see it. I'm gonna put it in, I guess, like that. And so anyway, um, it's easy to get the batteries reversed on this thing. So bust out the label maker, at the very least. But if you want a little bit more protection, not only, so what happens when you have the polarity reversed? Well, the polarity is reversed and you plug it in the goggles, you can fry the goggles, which is worst case. The other bad thing you can do is if you press the button here, I got another one here, so press the button, and the polarity is reversed, you'll blow out the LEDs, which is no good. Well, you'll blow out a chip on the LED board. Also not good. So how could this have been such a big oversight by Fat Shark? Well, they designed it for a battery, not a battery case, and so there's no way to reverse the polarity with just a battery because it's got a barrel connector and it's easy. You plug it in one way, it's done. The battery case came about, I think, because they had trouble because of the restrictions on shipping LiPo batteries around the world. They wanted to sell, their goggles and not have to raise prices and make people wait longer for the goggles. So they standardized on these 18650 cells, which is great. But they probably should have put in some reverse voltage protection. And you can see this case has been modded. Yes, looks like a tick's attacked my Fat Shark battery case, but no, it's not a tick. It is a FET, like one of the ones in here. And I picked some fairly big ones because I am only okay at soldering. And I figured the larger size would do right. It'd be easy to solder. And it also had the characteristics that I needed. So I spec'd it out. I spec'd out the part a little bit as best I could for low voltage drop, but I'll talk about that later. So anyway, that's why we want to mod this. We want to mod this so that we don't blow up our goggles, we don't fry the LED, and we can, if we've got other people using the goggles, or we don't have to worry about them putting in new batteries and messing it up. So what's the theory? So I found this TI app about reverse current battery protection circuits, and you can use a diode, but they point out that you'll lose about 0.6 volts. So instead of supplying 8 volts, you'll only be supplying 7.4 volts, which means that you don't get as much fly time on your goggles. So that's no good. But they can say you can use a FET, and if you choose one correctly, you can have almost no voltage loss. And so all the power goes to the goggles, and you get your cake and you can eat it too, basically. The disadvantage is the FET's a little bit more expensive, but hey, you know, $2 to save $200 worth of equipment is that's a great deal. Okay, so I'll put a link to the paper here, and you can read the paper, and yeah, boring stuff. All right, so that's the theory. Does it work? Okay, so you can see that we've got a MODI case. What I did was I put a I put the FET up here, and if I were to do this over again, yeah, I know it sticks out a bit. What I could have done is I could have left myself more leads. I could have not cut the leads so short here, and then I could have bent this over so it's flush against here, and then shrink wrapped it and hot glued it, and that would have been better. And if I were to do this over again, I would totally bend this down and make this flush with the case here. But you know, lesson learned, and you guys get the benefit of the experience here. So, okay, does this work? So first, let's take a look and see how much voltage we're losing, because I picked this out and it's got like 1/8 of an ohm of resistance for, I think it's RDS, and that means that, well, what did I figure it out? If you're pulling 1/2 amp, it's going to be very little voltage loss at all. All right, so the center is hot, and you can look and see here that we've got, it's like 7.79 volts, okay? And so that's with the circuit on. All right, so let's just put them in a normal battery case and see what the voltage is. This is a battery case that has no modification to it, no tick, yeah. So we'll measure the voltage here. 7.79, 7.8. It's so close that you don't even really get a difference. So we are keeping all our voltage. So awesome, that's working. All right, the other thing is, and while I take out these batteries, I'll talk about it. What happens if you leave the batteries in the case overnight? And I did this accidentally, reversed, and then I did it on purpose with the normal polarity. And it was at 7.79 yesterday, and it's still at 7.79. So it hasn't, there's no, the leakage current is very low. Now if it were winter, I probably wouldn't want to leave it for like months and months on end, but that's, I think, for any battery. You're not going to want to leave it in the case for extended periods of time. All right, so you're like, okay, well, does this thing work? Let's put the batteries in backwards and see what happens. And let me make sure they're in backwards. All right, so they are in backwards. And this case is tricky to get closed. And so let me look and see what the voltage is real quick. All right, now you watch the voltage here as I apply this. Now watch quick, because see, you get a spike and then it clamps down. And it doesn't spike up too much. It spikes up to like 1/3 of a volt. I've actually got that reversed. The plus is on the outside now. so I can do it. I'll do it again. See, it's already, and I don't know if that's a interaction with the multimeter or what, but it takes a little bit. There's a little bit of a transient there, but it is not 7 volts. It's nowhere near 7 volts. So you've got some protection there. And just for fun, I'm going to press the button here. No lights. Okay. So if that was fully, if you were getting the full current, I would have just fried my lights. I would have just fried that that board. So let me put it in the right way and see if I fried that board. Put it in the right way. Oh, 3 bars, which is how I remember it. So I've protected my battery indication circuit, and I would protect my goggles. Now I'm not going to plug them into my goggles the wrong way because I'm not that crazy, but I've measured on the multimeter and it protects this little $5 board, which I'm willing to risk. All right, so it works. So do you want to do it? How do I make this mod? And I'll cut to some pictures or some video of me doing some fairly mediocre soldering, and then you can see how I did it. Basically, to give you the top-down view, what you need to do is you need to pop the top off this battery case, and then you need to drill a couple holes. You need to drill 3 holes at the top here, so that you can fit the FET. And then you need to desolder the plus wire, solder it onto one of the FET legs, solder another FET leg to ground, and solder the other FET leg to the... So it's just some minor soldering here. It's pretty easy, actually, because like I said, I'm only an okay solderer, and I was able to get it to work. Now maybe if you picked a different part, you might be able to get it stuck in this case, and you might be able to do a lot better looking job, and if you got it all hidden. But like I said, I picked out this FET, and I knew it would do the job. It could dissipate any heat. Sorry, so like I said, I picked out this part. It's probably overkill, way overkill. You feel free to pick out your own FET if you like. I'll tell you which ones I picked out. I'll link them. So anyway, let's cut to the some awesome soldering on my part. Okay, now that you have the case open, you're going to position the MOSFET on the battery side, outside the case, put some score marks so that you'll know where to drill 3 holes. Alright, so I'm going to go do that, and we'll be right back.